All right, good day everyone. So, this recording will serve as my discussion for the entire week. Every time you forget or if you think you need more discussion, you can go back to this video, you can listen to this again. But the most important thing is, I'd like you to take down notes and that will be checked on Monday. Okay? So, this discussion again will be for the entire week already. So, in class, we will only do activities, we will only answer activities. Discussions will be done and done here and will be recorded. All right, let's begin. For this entire week, we will be discussing on representing and graphing linear relationships. Previously, you've learned already that in a linear relationship or a linear relationship can be represented by a line graph, just like what you see here in front. Now, in this particular line graph, we can actually see, or in this line graph, we can actually see the coordinate plane, or we make use of the coordinate plane to create any graph, including your line graph. So, in the coordinate or Cartesian plane, we have here the x-axis, and we also have the y-axis. So looking in this particular example, our x-axis is actually labeled with the quantity distance in miles. So the distance here is in terms of miles. And of course, the y-axis is the cost in dollars. So this is according to the graph. So every time you're given a graph, you have to analyze what quantities are being related. It's very, very important for you to understand. So for example, if you try to look at this one, if you try to pick a point, you say covering 4 miles, that will already cost, all right, $11. So you have to know what the x-axis is, what it represents, and what the y-axis represents. Now, further, if you try to look at it, between distance and cost, distance or rather cost depends on how far you have traveled. So between the two, distance is independent, whereas cost is the dependent variable. Likewise, it's also very important for you to know which of the two variables depends on the other. Now, in standard, x-axis is where the independent variable should be placed, and the y-axis is where the dependent variable should be placed. That is why we usually represent, or we always represent, the independent variable as our x and the dependent variable as our y. It should never change. All right? That's the standard that we follow in mathematics. You may pause this video, you may listen to it again if you wanted to, but most importantly, take down notes because those important terms I've mentioned a while ago will be repeatedly mentioned in class as well. So it is already expected for you to know what x means and what y means. What variable I'm referring to when I say independent and what variable I'm referring to when I say dependent variable. Okay, let's proceed. So by the way, this is the first way to represent linear relationship by means of graphs. Now, last time we started as well with a story problem or with a situation. All right? And from this situation, we were able to come up with a table of values. And from the table of values, I ask you to come up with observations and patterns referring or leading to linear relationships. Okay? And you're able to find out that a table of value exhibits or shows a linear relationship if, all right, if the x or the independent variable shows a constant interval or for each time your x changes with a constant interval, your y changes as well with a constant interval, which may not necessarily be the same interval that with the x, for as long as the interval or the changes in the y is constant. In other words, a table of values which shows a constant change in the x resulting to a constant change in the y is an example of a linear relationship. And in the previous week, you were able to see that we can only come up with a line graph if the table of value shows these characteristics. A constant change in the x, as what you can see here, leading to a constant change in the y. But the change in the y may not be the same that with the change in the x. For as long as all throughout your y, the values changes by the same amount, as well as your x, the value changes with the same amount as well. So again, it's very important here that you identify the quantities x and y. What are the quantities represented by the independent and the dependent variable? Now, when we come up with a table of value, we don't include the label as to what x and what y is. It should already be implied. Or you can write it on a separate part just for you to be guided as to what quantity is being represented by x and y. So in this case, the x variable, which is the independent, is the number of days the assignment is delayed or passed late, and the y is the maximum point. So you can see here that as the assignment is being submitted late, the maximum points decreased by 2 each day. All right? And this is the second way of representing a linear relationship, that is by means of description and table of values. Again, you can pause this video, replay, and take down notes. Okay? And of course, from the table of values, we can actually extract what we call as ordered pairs. So for each x, it comes with a specific y value. Okay, so you can have your 0, 30, that's one pair, 128, that's another pair, and so on. Okay, so these are our ordered pairs which we were able to get out from the table of values. So we have 0, 30, 1, 28, 2, 26, and so on. Before we had a term break, we had a discussion on this. Now, in an ordered pair, the first value is the x coordinate, or we call it the abscissa. Take down notes, please. Remember this one because I will be using the term abscissa as well. So the x coordinate or the abscissa, and the y coordinate, the second number is the y coordinate or the ordinate. Okay, so this is what we call as an ordered pair. Now, why do we call this an ordered pair? It's because it should come in this particular order. Okay, so your x coordinate should come first before your and then follows by your y coordinate, which is the second number in the ordered pair. Okay, now it should not be interchanged, otherwise that would be another value, that would mean another thing. All right, now for you to understand what I'm saying, for example, if we try to look at this Cartesian plane, okay, so if in case, let me just show you quickly. Okay, here. So if in case I would have, let's say, if I'll have 0, 30, for example, so that means the x coordinate is 0, the y coordinate is 30. So 0, 30 would be, we don't have a movement along the x, and we move along the y-axis, this one, 0, 30. This is now 0, 30. But if you say 30, 0, if you happen to interchange it, 30, 0 means we move 30 units along the x, which is this, but then there's no movement in the y, and this is 30, 0. So basically, interchanging the x and the y coordinate would result to a different point, will be interpreted in a different way. That is why we should not interchange the x and the y coordinate. All right? That's why we call it ordered pairs, because there is a certain order that the numbers within the parentheses follows. X coordinate first, followed by the y coordinate. Okay? So please pause this video or you may replay, but the important thing is to take down notes. Okay? So basically, we already have discussed four different ways of representing. We have the graph, we have the description and or table of values, and this one we already have the ordered pair. Okay, and from the ordered pair, we can use the ordered pair in order to produce the graph of this particular situation. Okay, so in this case, we can actually create a graph out from the ordered pair. So previously, we have determined already the x and the y, the independent and dependent variable, and we were able to produce table of values, and from the table, we were able to get the ordered pair. Okay. Now, if you try to inspect each ordered pair, all the points are in quadrant 1. Now, if you're confused what quadrant 1 is, that was your assignment during term break. There is a video in ManageBack talking about quadrants. Please check it out in week 0. Okay? Watch it again and study it. I won't be discussing it anymore. It's your assignment and your task to do it. All right. So all the points are in quadrant 1. That is why my graphing paper focuses only on quadrant 1. Okay. Now, here I don't have a label yet in my x and y axis because you are the one who will adjust. So looking at the x coordinates, the interval is only 1. Okay. So if you try to look at it in my x-axis, which is the number of days delayed, okay, so if we try to, by the way, you have to label this here number of days delayed. That's why you need to identify the um, quantity because you are going to label your axis according to the quantity and not just simply x and y. Number of days delayed and your y, this is your maximum points. Okay. So again here, if we are to choose a certain if you are to choose here a certain interval, it's all up to you. But if you choose to follow these intervals like 0, 1, 2, 3, 4, then you will only occupy this area here. And that might be very narrow, very small, okay? And you have a very big Cartesian plane. So instead of having 0, 1, 2, 3, 4, you can actually widen it up by adjusting. So instead of having an interval of 1, you can have an interval of 0.5. But then you don't have to write the 0.5. So it's, in other words, you can say this is 0, this is 0.5, you just have to skip it. So your 1 starts here. And then this will be skip, this will be 2, skip 3, skip 4. At least you're able to use this portion. And it becomes, your graph becomes a bit wider. Okay? So again, it's your choice when you create or when you label your x-axis, but make sure to maximize the space. Now for the y-axis, if you try to look at it, all right. So for your y coordinates, if you try to look at it, it's 30, 28, 26, 24, 22. So 30 is like a bit far. So you can, it's far from 0. So since all of them are divisible by 2, then you can have an interval of 2, depending on how your graphing papers can accommodate it. So from 0, you can have 2, 4, 6, 8, 10. So in this case, we don't skip this because, again, 30 is far from 0, so we need a lot of spaces above it. So instead, we adjust the interval not by 1. We can have it by 2. So 2, 4, 6, 8, 10, 12, 14. We can have it by 3, 3, 6, 9, 12, and so on. But if you choose an interval, you have to put in mind that it should not result or it should not cause you to have difficulties when you plot the points. Like for example, if I have this by 2, So 2, 4, 6, 8. So 2. In the middle, I know it's 1. So whenever I plot, say, 0, comma 1, 0, comma 1 will only be here. And it's easy because it's in the middle. But if you choose to have this interval as 3, so 0 and this will be 3, this will be 6, meaning if this will be 3, if I'll plot 0 to 1, then I'll have to estimate where 1 is located. So this is 1, that's an estimate, this is 2, that's an estimate, and this is 3. That that is what difficulty, or that is how difficult it is. So make sure that when you choose intervals, it would not cause you to have difficulties or encounter difficulties when you do plotting. Okay, so in my case, I've decided to have my y having an interval of 2 and my x having an interval of 1, and this is what happens. All right, so if you try to look at it, I'm trying to maximize the space here. So in my x-axis, I have 0, skip 1, skip 2. But I know that my interval is 0.5 along my x-axis. For my y-axis, my interval is 2. Now you might say, sir, why is this skip? No, I'm not skipping this. It's still 4. But then if I write all the numbers 2, 4, 6, 8, 10, the problem is this will be very much crowded. I don't want to see crowded numbers. Even without a number here, it's already obvious and implied that this is by interval of 2. So this is 2, and obviously this is 4. 6, this is 8. This will make it quite nicer to look at and not too crowded. Okay? So you don't really have to write all the labels. You just simply adjust. If you wanted to write, you may. Again, it doesn't matter. Remember here in the x-axis, this is supposed to be 0.5, but we're not writing it. So it's the same reasoning, not to be crowded. Okay. Again, what's lacking here is, so you need, whenever you are asked to graph, you need to write the quantities. So x is the maximum, the y rather is the maximum points. This is needed. And the x refers to number of days delayed. Okay. So this must be present. Otherwise, your graph would be will not be interpreted properly. All right. So now we can now plot it and graph it. Now again, before term break, we discussed on plotting of points, and there's also a video in week 0 on this. Those will not anymore be discussed. Review them, please. Look at the video. Okay. To continue, we now start to graph them using the ordered pairs we've got in the previous table. So 0, 30. Then you label. It would be better to label so that you would know and be guided that this is 0, 30. Then we have 1, 28, and so on until all the points are being plotted. Now, if you try to look at it, obviously, since this is a linear relation, this shows linear relationship, we expect that the graph would be a straight line. And if you try to look at it even, this shows or if a straight line pattern. So we can have 5 points, 4 points, or even 3 points. The moment you already plot the points, even if there are only 3, you could already see the graph, the trend. You could already see how it looks like. So in this case, if we connect all 5 points, we can actually create a graph. So even if I won't continue with this, no, this is what's good about graphing. Even if I won't continue plotting the points here, or even if I only stop with 4 days and then 22 marks, if you already have the graph, you could already interpret that all points found on this graph, because a line is composed of just simply points. All points found in this line are actually part of this. So meaning we can interpret that in 5 days, the total number of points will already be 20. Even if it's not found here, that's part of our analysis, because this is part of this point is found on the line. Therefore, this point should be part of this data here. And then you can also interpret that in 6 days or after 6 days, the total number of points would be 18. See, that's how beautiful the graph is, because you could already tell the other data even if it's not found here. Now, the reason why I wanted you to plot many points, it's because the more points you plot, the more accurate your graph is. Sometimes if we only plot 2 points or 3 points, your graph might not be as accurate as how it should be. Okay, it might not be like hitting the other points because you only have two. So having more will be you will be more guided when you connect them in a line. All right, and this is how we produce the linear graph. Again, pause this video, replay if necessary, but then most importantly, copy down notes. All right. Let's now proceed to part two of this video. It is moving from one representation to the other. All right. Now, previously, you've learned already that we can represent linear relationships, number one, by means of a description. Okay. So this is the story problem or description. We could also represent linear relationships by means of table of values, also ordered pairs, and of course by means of graph, which is a line. Now the thing here is we can actually move or shift from one representation to the other, meaning given a representation, we can actually extract data that will allow us to create the other representations. For example, if you're given a linear graph here, all right, so this is one way to represent. You can actually extract ordered pairs from this, okay, such as 2 comma 7 from the points, okay. You have here 4 comma 11, 6 comma 15, 8 comma 19. Again, there is an activity in week 0, which is your assignment in term break, on naming a certain point, which is found on the graph. Again, I won't discuss that. Study it, review the video for you to be guided. So the moment you got the ordered pairs, so I only got here 4, but we can have many. But the moment you get the ordered pairs here, you could already create the table of value. See, from the graph, you were able to create an order, or we were able to extract ordered pairs, which is another way of representing your linear relationship. And then we arrange the ordered pair, of course, starting from the x. Okay? We arrange it and we identify what these x values are. X value is the distance in miles. The y values are the cost in dollars. So we can create a table of value already. We're in x, the independent variable is the distance in miles, y, the cost in dollars. So we have 2, 7, every 2 miles, that's $7. 4, 11, 6, 15, 8, 19. Again, I encourage you to put the name of the quantity because that will give meaning to the numbers. If you will not put the quantity, if you will just simply write x and y, you will say x is 2, y is 7, and you don't know the meaning of that. It's nameless. It's difficult to analyze. Okay? Whereas if you have the quantity, then you can say, okay, 2 miles results to a cost of $7. 4 miles, $11, and so on. That's why it's very important for you to put the labels, to name the quantities. Now, from here, you can create your own story problem. So creating a story problem would depend on the person. So here you can create your own versions. In my case, if you want to make it simple, we can just say, by the way, before that, since we talk about taxi costs, so if you try to look at it in this graph, we can see that when there was no miles covered, the cost is $3. What does it mean? It means that the moment you board the taxi, the moment you go in the taxi, automatically you are charged of $3. We call it the flat rate. Okay? So from the story problem, we can say a taxi's flat rate is $3 with a succeeding charge of, so if you try to look at it, how much are you being charged? So from 7 to 11 to 15 to 19, that means an interval of 4. So with a succeeding charge of $4, and you are charged of $4 every 2 miles. That's also one importance of knowing the intervals in the x and the y. So if you try to look at it, here in the x, every 2 miles, or every changes in the x, which is 2 miles, it results to a change in the y, which is $4. That's how nice a linear relationship is, because the changes in the x is constant as well as the changes in the y. So again, we can interpret this as every 2 miles, every change which is 2 miles, the y changes by $4. So we say a taxi's flat rate is $3 with a succeeding charge of $4 every 2 miles travel. And this is now our description. Okay? So you can pause this video, replay, and copy down notes. And this is how you can shift or move from one representation to the other. Let's now have another example. Suppose we have a description. A certain experiment wishes to convert degrees Celsius temperatures to degrees Fahrenheit using the formula. So this formula might be familiar to you already. All right. Now, if you try to look at it, since the experiment says converting from degrees Celsius to degrees Fahrenheit, so here we can assume degrees Celsius as our independent because it is from Celsius to Fahrenheit. That means you cannot identify your Fahrenheit unless you know your Celsius. So degrees Celsius is the independent. And then the degrees Fahrenheit depends on what value of the degrees Celsius is given. So degrees Fahrenheit is your dependent variable. All right. So from here, we can see from the table, this table is taken from one of the sources in an experiment. So the table shows here different data. Okay. Now, since there are many, if we are to produce, also, by the way, from this description, we now have the table of values. Here, we can extract ordered pairs. Now, since one of our goal is to graph this, we don't have to extract all. We can just extract 4 or 5 points. Okay? Now, inspect your table of values. Your x values, which is the degrees Celsius temperatures, are in an interval of 5. Whereas your y, which is in degrees Fahrenheit, is in an interval of 9. Okay? So perhaps if you wanted to graph this, we can just plot, since your y is um, is with an interval of 9, so you can just simply like plot 4 points or 5 points, but it should be close to each other. When I say close to each other, if you are to choose, say, 0, and then if you are to choose 15 next, and if you are to choose 30 next, look at how the y changes. So 0, 32, 15, 59, 30, 86. That might be very difficult when you plot it because you have to show 32, 59, and 86 on your Cartesian plane. So you can just choose those that are closer to each other, like 0, 5, 10, 15, 20, so that it will be 32 to 68 if you wanted to. Now, in my case, I wanted to stick with smaller values, so I'm choosing this one because from 20 to 0, it's still, it's not that far from each other. And then negative 4 to 32, still it's not far from each other. So that is what I am choosing here. I'm extracting ordered pairs out from this. Again, it's all up to you on what ordered pair to extract, but make sure put in mind, this is part of your task. Whenever you choose ordered pair from a given table, make sure that it won't lead you to have difficulties when you plot. Okay? So you have to be wise as well when choosing ordered pairs. However, even if I've chosen negative 20 to 0, x values, which is my degrees Celsius, still the interval is 20, 15, 10, 5, 0, which I have to adjust in my Cartesian plane. Also, for my y, it's negative 4, 5, 14, 23, 32. I have to choose the correct interval as well. Okay? So that it won't be difficult to graph them. All right? Again, our x value is from negative 20 down to 0. Our y is negative 4 to 32. So I can now use this certain Cartesian plane. Okay, my x is, let's recall, x is negative 20 to 0. So I have here negative 20 here to 0. So I'll be using this. Sometimes there are students who would want to have it by negative 5. So you can have negative 5, negative 10, negative 15, negative 20. That's also fine. But if you have a big Cartesian plane, you have to maximize the space. So I have here by 2. The interval in my x-axis is by 2. because I could still cover all. For my y-axis, my interval is also 2. All right, let's begin. So I have negative 20, negative 4. So negative 20 here, this is my x, then negative 4. All right. Then I have negative 15 and 5. So negative 15 here, then negative 5. Negative 15 here. Wait, let me just check. Negative 15 and positive 5 rather. Negative 15 here, and then negative 15, that's my x, 2, 4, this is 6, so 5 must be somewhere in between. All right? This is what I'm telling you. You have to choose interval at which it won't be difficult for you to plot. Since I have here by interval of 2, so I would know that 15 should be between, negative 15 should be between negative 14 and negative 16. All right? And then 5 should be between 4 and 6. If you chose another interval, it's fine for as long as you know how to plot it. If it would lead you to have difficulties in plotting, then maybe choose another interval. But if it can't be avoided, if it cannot be avoided, then you have to go on with it. Just simply estimate and estimate accurately. Next, negative 10, 14. Negative 10, and this is 14. Next, negative 5, 23. Negative 5 is between negative 4 and negative 6. Then you have 23 between 22 and 24. All right? Wait, let me just delete this. It should be quite accurate. So negative 5, is it negative 5? Yeah, negative 5, 23. Negative 5 and 23. It should be somewhere here in between. And then you have 0, 32. 0, 32. Okay. So we now have plot all 5 points. So we can already connect them. Use your rulers. Okay. So connect them using a line. It should be a line. All right. Sorry. So connect with a line. Okay, this one. Okay. So when you connect it with the line, it should not be limited only to this. You should extend the line. Why? If you try to look at it, there are values in the table of values which are not included because we only plotted negative 20 to 0. How about this one? 5, 10, 15, 20. If you created an accurate line, actually, class, um, they will already be part of the line. So if you try to look at it, if I extend here, okay, say for example, I'll choose this point here. This point is found on the line. Therefore, this point is part of the data. All the points that you can get out from this line or all the points found in this line are actually part of your data. That is why you need to extend to show also the other points which were not plotted. So again, going back, if I'll choose this point, I'm choosing this one because it's exact. It's on the grid, so it's exact. I can easily find it. So if you try to look at this point here, this point here in the x represents 10. In the y, it represents 50. So we can say that if you have a 10 degree Celsius temperature, it gives you a 50 degree Fahrenheit temperature, or it's equivalent to a 50 degree Fahrenheit temperature. So 10 for Celsius, that's 10 for x, 50 for Fahrenheit, that's 50 for y. So let's try to see in the table. So you have here 10 and 50. We did not plot it, but already we were able to observe it. Now let's try to find 30 and 86. Let's try to see if it's found there. So 30 is here. So we have to see, sorry, 30 is here. Let's try to see 86. If it's really 86, 30, let's find 30 here. 30 is here. Indeed, it's 86. So see, even if we plot only like a few points, if you extend the lines, then the rest will be already included. So you don't have to plot all the points. Okay? And that's it. Okay? If you wish to know the website of this, the site or the link of this, I will send this in the description. I will send this in the Google Space. Okay, and that's all for my discussion. This time, it's your time now to do practice exercises. So I'd like you to answer this in your notebooks, and this will be checked on Monday. Now, on Monday, I will give a pre-assessment just to check if you have viewed this video, and that will be the basis of me providing you exercises. So I will, aside from checking down your notes, aside from checking the answer to these exercises, I will also provide pre-assessment. So make sure that you really watch this video, take down notes, and study carefully. Okay, so this will be your practice exercise. So I'd like you, given this particular graph, I'd like you to extract ordered pairs from this graph. That's the first. Arrange the ordered pairs in table of values. And once you have done that, make your own story or description, but you have to emphasize what the independent and the dependent variable is. So when you come up with your table of values, you have to identify what quantity is the independent variable referring to, as well as the dependent variable referring to. I think it's easier because you can see it from the graph already. There are labels, so you would know what the independent and dependent variables or quantities are. And you could also see here the label, the name of this graphs, and this will help you make your own story or description. Okay, because this graph has a meaning, and this graph shows this, and you have the quantities. Right, so try to do it on your notebooks. Number two, you're given here a story problem or a description. From the description, make a table of values. From there, extract ordered pairs and produce the graph. Make sure that you emphasize the independent and dependent variables. And number three is the same thing as number two, but this is a bit challenging already. So this is now a challenge. Okay? And that's it. Thank you so much for listening. Make sure to follow instructions and hope you learn out from this video.